Hello and welcome to an introduction to Azure MLOps or machine learning operations. This presentation aims to discuss the MLOps process through an Azure machine learning implementation. The presentation does not go into machine learning details and assumes the viewer has a cursory knowledge of machine learning concepts. The presentation will concentrate on the process of creating a model, experimentation, deployment, and monitoring in a similar way software engineers utilize DevOps to build code, test, deploy, and monitor applications. Right, moving into the agenda for this. First of all, we'll take a look at the machine learning process. Machine learning has its own process around how you go about collecting data, creating features, and building a model. Once we understand that, we'll go into Azure machine learning features, as well as the Azure machine learning service. Understanding the features in the service lends itself to understanding what Azure machine learning pipelines are and how they fit into the Azure machine learning operations process. Once we have that and a good understanding of the features, services, and pipelines, we'll move into a demo. Let's move on to the machine learning process. Machine learning is a data science technique that allows computers to use existing data to forecast future behaviors, outcomes, and trends. The first thing that we need to do when looking at machine learning and data science and the whole technique around using existing data is to define the problem correctly and asking the right questions around the problem domain. Having a really good business understanding and being able to articulate the types of problems and the questions very well is very important. Once we have the problem, we can go and then extract and collect the data. That's just a typical extraction process of getting into the source systems or into your data warehouse, getting the data out, profiling that data, looking at the types of data that's in there, and most importantly, can that data help with trying to understand or articulate the problem and answer the questions that you originally put in the original problem statement. Once you've cleaned and profiled the data and you've got a good understanding of the data, you move on to feature engineering and feature selection. Feature engineering is a technique whereby you're looking for features that are going to give you the best possible outcome in your predictions of your model. And having a really good understanding of your data and a good business understanding is where feature engineering really comes into play. It's not purely a data science technique. You have to involve the business in these decisions because they're the subject matter experts. And they'll be able to tell you whether or not there's a correlation between what problem you're trying to solve and the feature you're trying to engineer. Once you have that in place, and you have your number of features selected, also known as variables, you then go into model selection. Model selection is really about selecting the right algorithm to train the model. What you do is you take the data that you've gone and feature engineered, you split it into 75% for what they call training data and 25% for testing data. There are other techniques that you can use as well around cross-validation techniques. I'm not going to go into those right now, but essentially you train your data on the 75%. You tune your model a little bit around that with hyperparameter tuning. And when it comes to model evaluation, what you're doing is you're taking the data that was trained and the model that was trained on that data, and now you're going to evaluate it against some test data. And once you evaluate it against your test data, you get a whole chunk of results back about how well your model performed. And there are a number of variables that you would look at to determine whether you had a good model or not. As mentioned previously, I'm not going to go into full data science behind this, and there's many PhDs out there that could probably give you a really good understanding of the science behind model evaluation. But once you've gone through that model evaluation, you may have even put together a number of models and then chosen the best model out of those. You need to go and deploy that model. And this is where the MLOps part really starts to come into play. So from defining the problem to the model selection is the data science process around, selecting the right models, feature engineering. We're going to talk about experimentation in a moment. But once we deploy the model, that's the hard part that a lot of people struggle with, because we need to treat a deployed model just like you would treat a deployed application. There's different ways in which you can infer your predictions. So there's what they call batch inference. So that's typically give it a batch of data, let it run on it, and once it's completed, you can either give it another batch of data or you can wait until the next day. So it's typically run once a day, once a month, once a week, etc. Real-time inference is a little bit like the engines that you have on Amazon. So, let's say we've got a recommendation engine and it says you bought this particular product. You may also want to buy this product as well because other people found it useful. And then finally, there's the edge deployment, where you want very, very quick real-time integration. An example of that is self-driving cars. When it predicts or sees something in front of you, it must apply the brakes as quickly and as efficiently as possible. So that's, at the edge deployment, that's what that means. And finally, then, on a continuous basis, we need to monitor our models for performance. We also need to monitor our models, because what happens is especially in the business domain, data can change, and so you get something called data drift. And so when that happens, you will need to go back and train the model again, redeploy, and get the model into production. Now that we have a good understanding of the Azure machine learning machine learning processes, let's have a look at Azure machine learning specifically. So Azure machine learning is a service on the Azure platform. If you have an Azure subscription, you can just go and create a new Azure machine learning resource. Once you've created the resource, you get the Azure machine learning workspace, which you can then open up and get a number of features inside of it. So there are some features like domain-specific pre-trained models that are really captured outside of machine learning, and that's why that grey line is there. This is more captured inside of cognitive services, and there's a number of things there around vision, speech, language, and search that you can just use already pre-configured models that already know how to go and really understand vision and speech and so on, and you just have to provide it with a number of inputs, and it'll train on your inputs, and then you can use those afterwards. Azure Machine Learning also has a number of familiar data science tools that you can use in it. PyCharm, Jupyter Notebooks, very popular. Visual Studio Code, which is popular on the Microsoft platform, and command line utilities as well. So linking into those. Popular frameworks are always supported: PyTorch, TensorFlow, scikit-learn, or scikit-learn, Onyx, and so on. You'll notice that a lot of this is very much geared towards the Python frameworks and libraries. At the moment, R is on the roadmap, but is not currently in the Azure Machine Learning platform environment. We move on to productive services. So if you've got very large sets of data, you can put your data on Azure Bricks for that, kind of scale out kind of environments, especially when you're training very large sets of data. Azure Machine Learning can create its own clusters, and there's some very special things that you can do in there around parallel runs to enable much faster training and learning when you've got things like multi-models. And then finally, you also have a number of pre-configured machine learning VMs that you can use. And finally, it supports CPU type of learning, but it also supports GPU for that really deep learning that you may require. And finally, edge deployment through FPGA devices. So moving on to machine learning services, this is really where we take a number of Azure cloud services around the machine learning SDK. We combine that with some Python SDK for developers to really be able to, instead of using a drag and drop interface, just to be able to code inside of, on a Databricks environment, to be able to code in Jupyter notebooks. And from there, you can do everything that you'd like to do, from preparing your data, training your models, building your models, managing your models around registrations and model versions, etc., as well as all of the dependencies that go with them. It allows you to track experiments, and I'll show you some of that in a moment. And finally, allows you to also deploy models, and that's all through code. So, when you look at at DevOps, and I'll explain a little bit about DevOps in a moment, but when you look at DevOps, the whole point is to be able to deploy both your infrastructure and your code, and not have to do any manual deployments or any manual configuration. And so the minute you bring these two services together, you're building that capability of being able to have everything in code and not have to do any manual configuration. So what are Azure Machine Learning Pipelines? So a pipeline is a certain task that you'd like to have performed within the machine learning or Azure machine learning environment. They allow you to have a pipeline, for example, to prepare data, or you could have several pipelines in preparing data. For example, you could have a pipeline that ingests your data, then a pipeline that transforms your data, etc. And then you can have a separate pipeline that builds and trains your models, and finally a pipeline that deploys and does your batch scoring as well. So one of the reasons why you want to have a number of different pipelines is you want to make use of parallelization in the platform, especially when you're using things like multi-models. If you've got a number of models that you want to train over your data set, then what you're doing is by having separate pipelines to build those models, you can then in parallel train and build those models as needed, and you can speed things up quite a bit. We've seen parallelization runs go from what was 3 hours to 25 minutes for 200 odd models. So utilizing Azure Machine Learning Pipelines is quite important, and that comes, you can use a pipeline either in the SDK, or you can use it inside of Azure Machine Learning in the Workspace, which I'll show you in a moment. So what is machine learning experimentation? Just like you have science projects and you have, a hypothesis, you go and you run an experiment, and then you observe, you have your observations and a conclusion out of that experiment. Exactly the same thing happens in data science. So that hypothesis is that business question that I said that you want to solve, or the question that you want to solve. Grabbing your data and then munging your data into something, and feature engineering, and then running some models over it and having a look at the evaluation of that, is that whole point around observations that you get as you go through different data points, different features, and different parameters tuning. So the whole experimentation process, you want to be able to track that. You want to be able to track your data sets that you were using. You want to be able to track your features that you've been using. You want to be able to track, the performance of your model over time. And you also want to track your hyperparameters, whether you're using both machine learning or deep neural networks. All of those together, every time you run a model train, you can capture all of that data. And the next time you run a new model train and testing exercise, it creates a new experiment. And so you can capture this over time, and you can actually compare the different metrics from the experimentation over time to eventually build up the best model that you can and the best features, best data with the right outcome. Once you've selected the right model from the experimentation process and you've created that model, you want to be able to go ahead and deploy that model. You want to register that model as a deployment, track the version of the model, and as well as track its dependencies. So just like you would deploy an application and it had a number of dependencies on that application, you need to be able to deploy your model and track the dependencies and have those dependencies deployed with your model as well. And then finally, you want to monitor that model over time. As mentioned earlier, you want to monitor for data drift. You want to monitor its performance, not only its performance in terms of how quickly it can do the inference of data, but also its performance against the original results that you had in your experiment. If you're seeing your model degrade over time, you're going to have to go back, retrain that model, re-register a new version, and then carry on the monitoring. So just like you would any application, you need to manage your models and monitor your models in the same way. Right, finally, we move on to Azure MLOps. So this is bringing machine learning and DevOps together in one process. If we look to the bottom of the screen, you'll notice the DevOps process. You'll see the infinity sign, which is around, if we look to the development side of things, where you plan, create, verify, package up your development components to be released, configured, and monitored within the operations side. If we look at machine learning and the experimentation pipelines that we talked about earlier, we then have this additional process that we add to the DevOps process, which is that machine learning process that we've been discussing through the other slides. If we now look at the top part of the slide, we have our build and train models, hyperparameter tuning, experimentation, and pipelines all come into the initial machine learning process, and then the deployment and DevOps for data science parts that they're talking about there is we go and register our models, register all the packages that go with those models, all of the dependencies, etc. Then deploy the model, or create an image to deploy the model, manage and monitor that model through a number of different processes, and finally you go back to the original piece, which is looking at your model around data drift, monitoring its performance, etc., so that you can retrain your model and redeploy. So in essence, what the MLOps process is adding that machine learning process to your standard DevOps process. What we'll do now is we'll jump into a demo and show you some of the Azure ML parts of this process. So once I've logged into the portal and I've gone ahead and created my resource, my machine learning resource, in this case mine's called Versus Azure ML Demo. There were a number of resources that were created at the same time that the machine learning workspace depends on. So storage, a container registry if you're going to use container instances to do some of your either inference or training, a key vault to store your secrets, and application insights is very important, especially around the inference part, to monitor your performance of your models once they've been deployed into production. Once you're ready, you can just click on Launch Studio. I've already done that, and what that does is it brings me into this workspace environment. On the left-hand side, I have a number of different options. I have author, assets, and manage. So just talk about authoring. I can create my own Python notebooks. I can also use a feature called AutoML. I'm not going to go into that at this point in time. Or I can use a drag and drop designer type environment. The assets comes into that whole experimentation part of things where I want to register my data sets and my features. I want to run my experiments as mentioned previously. I want to split my different areas that I've got into different pipelines. So, ingesting the data, transforming the data, then training my model, etc. I want to be able to register my models. And finally, I have something called endpoints, which is all around being able to register an endpoint for inference purposes. Under the manage side of things, I have a compute environment. The compute is really split into a number of different areas, which we discussed in one of the slides, which is around, if I wanted to use Databricks to do, large data training, or I wanted to spin up an Azure machine learning compute cluster to do training and inference on its own, etc. I have something called environments, which is just in preview now, so I can have a dev, a test, and a prod environment within here. I have data stores around being able to register certain sources of data into this so that my users that come into this environment can only use those particular sources. I have data labeling, and I have other linked services as well. Just to give you an overview of what some of this might look like, so I'll click into notebooks. There is a whole bunch of new features that are in the notebook side of things. I can go ahead and begin creating a new file, upload existing files that I have. It very much uses the similar environment to Jupyter notebooks. So you can see there Jupyter notebooks directly in this workspace. So if you're already using Jupyter, you can just upload your notebooks in here and begin coding. I can also switch over to a terminal and begin coding in my terminal environment. I'm not going to talk too much around the automated ML part. You can come in here and see what it is about. But essentially you're running multiple models at the same time and choosing the best model out of it. Finally, we can go into a designer, very, very good for people that are just learning how to do machine learning. Brief look, I've got a regression model around automobile pricing over here, and you could go ahead and play with this yourself. It's one of the examples that they've got there, and it shows you how you can grab your data, split your data up, split it for training and testing. In this case, 70% for training, 30% for testing. We train a model on a linear regression algorithm, score that model against our test data, and then finally evaluate that model. There's a number of different, sample data sets on the left-hand side here, or any data sets that you have registered will also come in on this part. There's a number of data transformations, feature selection, options and so on in here that you can just drag, drop, and join them together. It's quite simple and easy to use. So to wrap up, I just wanted to talk about experiments. I've already run the price prediction model, and it created an experiment pipeline run for me. I can see the experiment in here. I can also see the pipeline run here. It gave it the name Wheat Snake. That wasn't me. It just if you don't give the pipeline a name, it'll automatically create a name for you. So if I just have a quick squiz at experiments, you can see the pipeline runs at the bottom here. I'm just going to click on this, and what you will see is you can see all the green saying how it was successful and it was completed. Down there, if I just look at this canvas, you can see it completed and evaluated the model, the different steps that it took on that, how long each one of those steps took. So each one of these is that little box that we saw on the Canvas designer. And I can have a look at, if I had logged any metrics, I could also look at metrics, logs and outputs, etc. as well in here. If I just go back to the experiment itself, one of the things I can do is I can build up my own charts. I can see experiments over time and see which experiment provided the best results, etc. in here. And so that wraps up what I wanted to talk about today. Thank you very much. If you want to contact us, please do so, and we can help you with any machine learning inquiries that you may have or your MLOps process. Our details are on the slide below. Thank you.